The next thing we're going to have a look at in ZBrush is how to retopologize the model so that we can use it in a visual effects pipeline. Critical from an environment technical director's point of view is having models which have technically correct quad-based topology which can be subdivided at render time, and clean UV maps which are detailed and unwrapped easily. Quad polygons are important for RenderMan subdivision at render time, but also for levels of detail for games and deformation in animation. UV maps are critical for textures and displacement in RenderMan, and critical for normal maps and baked shadows in Unreal Engine 4. So whatever rendering engine used to display the content, flowing quad geometry and UV maps that are technically correct are super important in either rendering package, whether you're using real-time rendering or whether you're using CPU-based high-end film rendering. So to build, retopologize this mesh, what we're wanting to do is create a low-res version of this mesh. So the first thing we're going to do is we're going to have a look at the line polyfill. Now if we zoom into this model, we can see here that this mesh is made up of triangles. And one of the problems with triangles is it doesn't have edge loops which are running through the mesh so that you can mathematically divide it and subdivide it into smaller and smaller sections. This is the way that RenderMan figures out displacement. So if we want to put a medium resolution version of this, these roots into Maya, and then put a ultra high resolution displacement map on, we can't do it with this model easily. So what we're going to do is we're going to divide this geometry. So we've got 5.388 million polygons. We're going to delete the lower subdivisions, and we're going to use a tool called Z-Remesher in ZBrush to retopologize this model. So where that is in Z plugins, in tools, we've got this Z-Remesher in here, and to get tools into the side panel, we can click this little icon on the top left hand side here. Now in this list down here, you can minimize and maximize each category of this list, and the one that we want to select is the Z-Remesher. So we'll go into geometry and open up that, and then down the bottom of geometry you can see here we've got this Z-Remesher drop down. Now on the Z-Remesher settings, you've got target polygons count, and it says 5. 5 is 5,000 polygons, not 5 polygons. We've also got a adaptive button here, half, same, and double. We've got an adaptive size, curve strength, use polypaint, and modify topology. So if we go onto half, turn off adaptive, and we look at our active points and total points up here. If we press Z-Remesher, that's going to reduce the polys of our mesh. So what we're going to do first is we're going to duplicate our mesh so that we can project the high resolution detail back down onto our low resolution mesh that we've retopologized. So what we'll do is we'll have this subtool here selected, and we're going to hit duplicate. Now, what we're going to do is we're going to rename this top mesh here, and we're going to call it retopology, and then this one's our master. So we'll go on to master. So we've got our master and our slave. So basically that's how the meshes are going to work. So we'll go back down to geometry. We've got half selected, and we'll hit the Z remesher button, and that is going to work its magic. So when you do this on the high resolution mesh, it's got a process up here. So you'll see a timeline bar go across the screen. So this can take quite a while to do on the first pass, and then each additional level that you go down, we want to really try and get this down to around 20 or 10,000 polygons, and that'll enable us to easily UV unwrap this model without too many problems. If you go too low with detailed models like this, you can actually damage the integrity of the geometry, and you'll miss out on all these holes and loops and things that are in there. So you've got to be careful that you don't low poly the design or the mesh too low, so that you're not able to wrap it and reproject back on the details of all these holes and tubes that are in the scene. So we've now got a model with 138,000 polys instead of 5.4 million. So we're going to hit this Z remesher again and drop another level of subdivision. We're going to hit this until we're down to about the 15,000 mark. So now we're down to 64,000 polygons, and we're going to hit Z remesher again, which is going to be a lot faster this time. And we're trying to aim to get this number low enough so that when we UV unwrap this using UV master in ZBrush, it's not going to choke the computer. So we've got 31,000 points, and we're just going to hit it one more time to go down to 15,000, and that's the number we're going to use for using Z remesher. So the way that you can now match this low polygon mesh over the top of the high polygon mesh, you can see here that we've reduced the polygon count, but we've also reduced the detail of the shape that we've got. So if we go up to our subtool here and we turn off the master, we can see here that we've actually lost the shape of our root system, and we've got this very basic kind of blobby Pixar graphics, cartoony graphics looking model here, where we've before we had this super detailed mesh that had millions of polygons of surface detail in there. All right, so we'll go back up to our low res one. Now what you do to project the detail back on and retain the detail is, now that we've got this lower level of subdivision, we can subdivide it back up really high. So we'll hit the divide button. Now we've got 64,000 points, 250,000, 1.3 million, and 4 million. Now, considering the original had 5 million points in it, this is close enough, because if we go higher, we're actually be going up to 16 million, which is too many polys for this model. So we'll go delete higher. So we've got subdivisions of 5. So the first subdivision level is 16,000 faces, and this fifth level is 4 million. So that's an excellent level of detail. So the next thing we want to do is project the geometry off our master onto our slave one. So the way you do that is you select the retopology geometry, and then you press this tab down here which says project all. This has got some default settings on it, and we're going to leave these at default, but in case yours are different, I've got 0.02 for the distance, 25 for the mean, 10 for the PA blur, and projection shell is 0. So I'll press project all, and this is then going to look at the normals of the high resolution mesh and do its best approximation to match the position of the retopologized mesh to the vertice position on the original triangulated mesh. So we'll let that process, and then we'll have a look at the finished projection, which should be exactly over the top of each other, except with the subdivision levels retopologized quad-based geometry, but it will keep all the detail in there of the geometry. So we'll see what that looks like when it's finished processing. So here we've got the projected high-resolution geometry over the original Agisoft PhotoScan mesh. So if we zoom into this, and we're going to go into our master geometry here, and we're going to switch that off. So with this line fill poly button selected, we can see that we've got this amazing flowing topology now over the shape. So if we have a look at this, these roots, for example, you can see here that the polygons are all split and divided and flowing down the right down the center of the roots with the geometry going across it. And similarly on this one, which is just super clever. I don't know how exactly this software is able to use maths to figure out how to retopologize this geometry in such an elegant and accurate way, the way it flows around these organic shapes. But it's just really clever at doing it. And the reason why this is so great is because now, instead of just having this ridiculously high resolution triangulated mesh, we now have 5 levels of detail of this model that we can use for all kinds of different purposes. So if we have a look at this resolution, this would be ideal for something like a mobile phone game, where you need to use the lowest possible subdivision level of the model with texture maps on it, whereas subdivision level 4 can easily be loaded into Maya because it's only 1 million points. Subdivision level 3 as well, 254,000 points, has got huge amounts of detail in it, which you can easily animate and walk characters along or do different tasks that require detailed intersection geometry. And the great thing about that is you can then use level 5 to as a displacement map to be able to add in the extra high frequency detail, so that you can when you render that, you can use the low detail mesh in the viewport and then render basically the high resolution mesh. So it's just a great system. It makes life so much easier to be able to work with this quad based geometry, which can be subdivided. The only thing you have to do now, once you've subdivided this geometry, is have a look at some of the way that the projection has reprojected the surface back on. Now you can see here, we've actually got a few little errors where the surface has gone all spiky on here. And the way that you repair that is basically to use the smooth brush, and to basically paint those details out, and repair them the same way as we did with the master high resolution mesh. The other thing you can do is change your projection settings and adjust it that way. But by using this smooth brush, you can easily modify and fix up any errors that you've got from the projection. Things like this spiky edges here and these pixelated looking extrusions that are on the top of it. This is all stuff that is from having a very low resolution base level of detail and then trying to project a very high resolution tessellated complex interlocking mesh over the top. So you do need to repair a few of these little sections of the model, but once you've done that, you should be able to get ready to UV map this model. So let's assume that this is ready to be UV mapped at the lowest subdiv level. So in order to do that, what you want to do is first of all save the file. So we'll press Control S to save the file, and we're going to put this into a folder, tree roots A1, and we're going to save this as tree roots A1 FX PhD version 01. That's the correct way to save your files in ZBrush. So what we're going to do now is we're going to UV unwrap this model, which currently has no UV maps on it. So what we're going to do is we're going to go into Z plugin. We're going to go down to UV master. We can put this panel on the side if we want. Now there's a number of panels in UV master. It doesn't have a lot of buttons, but the buttons that are there are super important. We've got the unwrap button, which is the magic button that smart unwraps this shape automatically without having to manually lay out all the UVs for it. We've got this polygroups button, which you can turn on and off. We've got enable control painting with protect, attract, and erase. And we've got work on clone down the bottom here. So the first thing we're going to do is we're going to press this work on clone. And what that's going to do is it's going to copy our lowest subdivision of our model and duplicate it so that we're able to work on a copy of our model rather than the actual one. And then what you can do is you can copy the UVs and paste them back onto your multi-leveled master model. That may sound confusing, but it's actually really, really simple. All you need to do is flick back to the other model and literally paste the UVs into it. It takes like 5 seconds. So we've got our clone here that has no subdivision levels. It's just basically a copy of the lowest subdivision level of the model. And at the moment, it's in one piece. If we go down here to polygroups, which is in the geometry menu, or polygroups, which is down here, we can see here that the model is in one polygroup. Now, polygroups are a way to break up the model into different sections so that you can work on them and hide certain pieces of it and do all kinds of different separate tasks. One of the great things about polygroups is it can make it really, really easy to UV map complicated, difficult geometry. So what you can do is if you hold down Control and Shift, that will open up this selection panel here, and that will actually allow you to select geometry and be able to modify it. So what we're going to do is we're going to go over to this brush up here, and we're going to click on the Select Lasso. And we're going to go onto this stroke, and we're going to select lasso on here. And then what we're going to do is we're going to slice this model into quarters, into sections like this. Now, once we've made this little piece here, what we can do is we can press group visible. And that's changed the poly group of the visible section of the model. Now to deselect and show everything again, all you need to do is press Control and Shift and tap once in the viewport. Now if we pan around, we can see that we've got one green section here that's one poly group, and one section here that's just this side, this root on the side here. So by breaking up the complicated models into several poly groups, you can create more efficient UV maps, because it's not just like going to unwrap into one giant sort of like unwrapped elastic looking shape. It's going to have sections and pieces that it can unwrap. So what we're going to do is we're going to go and just section off a few more pieces of this. So we'll go group visible. Group visible. Going to make this inside section its own group. And basically just drawing around and creating some different groups for this system to figure out how it's going to break up this shape. This is probably going to be enough for what we're doing here. And you don't want to make them too disorganized as well. It's good if there's some kind of rhyme or reason to the way that they are separated. So I'm going to leave it like this, and this is going to break each one of these up into a section and attempt to UV lay them out. Now if I go back into UV Master, there's a button here that says Polygroups. Now when you select this Polygroups button, it's going to try and cut these pieces up to make UV maps based off the polygroups that you've created. Now UV Master doesn't work like other UV apps where you actually hand select the edges of the seams of UVs and put them all together manually. It will do it itself, but it enables you to have sort of like guess input into what's the word? It's like suggestion input of where you want it to put seams. So if we put in here protect and paint in a surface here, this is going to protect that, try and protect that area of the model. And if I press attract, it's going to put seams into the model along these lines where I've drawn. Now, things like roots and things with holes in them and complicated pipe-like structures can be very difficult for UV mapping because of the way that they need to be unwrapped, flattened out. They're quite computationally difficult for the software to unwrap. But in any case, you can break it into polygroups, you can enable control painting, and you can do all kinds of things like that that help the software to figure out how to unwrap the model. So once you're finished selecting polygroups and breaking it up, you can press the unwrap button, and it will go through the process of cutting the model up and then set it into an unwrapped state. Once the model's unwrapped, you can have a look at what it looks like by pressing the flatten button on the UV Master tab. And this will show you what the UVs look like for that model, all flattened out in 0 to 1 UV texture space. Now, while these might look a little bit rough, once you've actually projected the UV maps back on in Agisoft PhotoScan, you'll get very, very highly detailed, super nice texture, detail out of these UV maps because they're very evenly spaced across a very complicated surface. So if we look at how complicated this surface is, I mean, there's tiny little roots everywhere. There's all kinds of different complex detail in there that it's been able to flatten out into these very simple shapes. The other thing that's good about these flat UVs is you can easily get images in Photoshop and paste them into this if you need to edit or upgrade the textures that Agisoft Photoscan creates. So that's basically a look at how you can UV map UV map models using polygroups and by using a low poly version of the mesh. So what we're going to do now is copy the UVs, go back to our main model, and we're going to paste the UVs onto this model. Now, once we've pasted them onto the high resolution model that we've created, we can now export this UV mapped retopologized model out to the different software that we want to use. So we can load these into Maya, we can load these into Agisoft Photoscan and texture them, and we can do all kinds of different things. So the first thing we're going to do is go down to subdivision 1, and we're going to go up to we're going to go here to the export button. We're going to click that, and then we're going to create a new folder here called, and we're going to name it tree roots _A1 _FX PhD training levels of detail. So what we have in here is the tree roots level of detail _1, because this is level 1 of the level of detail. So we'll save that. Then we'll slide this slider up to number 2. We can export that and name it number 2. Save that. So now we have 2 levels of detail saved. If we select this and go number 3, we have 3 levels of detail saved. The 4th level of detail, we'll name that number 4. And finally, the 5th level, we'll call number 5. Now, the 5th level is also the level that you'll be using for creating a displacement map, and we'll have a look at that in the next class. So we've got 1 to 5 levels of detail of the same mesh, and we can use that in all kinds of different software. Plus, we can subdivide it at render time using RenderMan subdivision scheme, Catmull-Clark scheme. So this is an excellent mesh that's really usable in a VFX pipeline and in a gaming pipeline that we've created in ZBrush from an Agisoft Photoscan high polygon mesh. In the next class, we're going to be having a look at how we can generate a displacement map to use in a RenderMan RAS pipeline with this model, and how to select the correct subdivision level to generate the displacement map, and the settings you use to be able to create that.